Well, hello and welcome to the Bumper to Bumper podcast. I am Dave Riccio, co-creator of Bumper to Bumper Radio and your host of the Bumper to Bumper podcast, sitting here along with Jon Riggle, lead technician at Tri-City Transmission and well-versed in every part of the automobile for a long time.
Long time, yeah. Let's just leave it at that.
Leave it at that. Now, I started in auto repair, I would say 30 years ago. I'm 47. By 16, I was working in a shop, but by 14, I was rebuilding small engines.
Yeah.
So it's been a long time. Did you start with small engines?
Yeah, I did. Yeah. We had motorcycles, go-karts, all that kind of stuff when we were growing up. I mean, it goes all the way back to 6 years old.
Oh, yeah. No, a long time. I learned a lot about engines from my grandfather. He and I used to sit at the kitchen table, and he always had a paper towel and a pen, and he would draw things out and show it to me. And I was always interested in how everything worked.
Yeah.
I wanted to know how everything worked, and it was never ending. But I don't think as much as you wanted to know how everything worked.
Well, no, it was a little different. I had to know because my dad would bring home things. My dad was a real practical guy. He was a machinist in the Navy. So he would bring home things like go-karts and stuff. None of them ran.
Right.
It was like, if you can get it going, it's yours and you can have it. So he would steer me through it and stuff, and we get the things going and stuff. So it just started out as almost a necessity for me. So
yeah, it's funny how hobbies can lead into whole careers.
Yeah.
So I get a lot of questions about O2 sensors.
Okay.
And I thought, hey, that's something we ought to cover because O2 sensors, when you pull into because you've got a lot of the auto parts stores, and I think this is why people are so familiar with O2 sensors. Mm-hmm. So their little yellow check engine light comes on in the auto parts store. They run an advertisement on the radio, and they say, hey, we'll diagnose your car, and you pull in, and younger kid comes out, and he plugs in this little device, and he gives you a little printout. It says O2 sensor.
Yeah.
We do have those, and they're $55 or whatever the math is on them. But I would say, in my experience, that a good majority of those O2 sensor codes don't actually end up in an O2 sensor replacement. So I think we got to know what the heck is an O2 sensor.
Yeah. Well, let's start there, but let's define that because that's an acronym. O2 is oxygen sensor, right? So that's a little bit of a misnomer in the automotive world, and we'll talk about that a little bit. They are not really oxygen sensors because we have oxygen sensors in like our exhaust gas analyzers that will interpret the amount of oxygen in our sample. The oxygen sensors in the tailpipe won't give us that kind of information. What they do is switch right at a stoichiometric mixture.
That's a big word, stoichiometric.
Stoichiometric, it's a chemical term. So if we have a chemical reaction, when we start our reaction, all those components that went into that reaction come out as something else, but they're all used up and they're all complete that chemical reaction in a balanced way. So that's stoichiometric. When we're talking about gasoline, you'll hear people talk about air-fuel ratio. Mm-hmm. Okay, and that's what we're talking about. We're talking about the ratio of fuel to air or air to fuel. And when we achieve a stoichiometric mixture, the only thing we have coming out the tailpipe is H2O, and we have a little bit of CO, a little bit of O2. But if it was perfect combustion, we'd have water and carbon dioxide coming out the tailpipe. We never achieve that perfect combustion, but we get really close. So ultimately, if our chemical reaction during our combustion process takes place, we have we have H2O and CO2 coming out the tailpipe. So that's fairly clean, right?
Right.
That's good stuff. There's nothing wrong with H2O. That's water. The CO2 is an issue for I want to say global warming. I guess that's what we want to call it this week or whatever. Yeah, climate change or whatever. But as our combustion efficiency goes up, so does CO2.
Right.
Okay, so these oxygen sensors respond in a way to the amount of oxygen in the tailpipe. Okay, but we can't really measure the amount of oxygen. We only know whether it's stoichiometric.
Okay.
Beyond stoichiometric, an O2 sensor either reads high or it reads low.
So essentially, what an engine is doing is it's taking the gasoline and it's mixing it with air or atmosphere, and it mixes it right at the perfect combustion level. Phone's always going.
Yeah, we'll do some edits here.
So we're mixing those two, and the perfect mixture is stoichiometric. That's where the combustion chamber,
Yeah.
and the combustion is what makes the engine go.
Yeah.
So that drives the engine. So then the O2 sensor, what that is used for is it's a messenger in a sense. So it's messaging the computer to say, hey, we got a little bit too much gas,
Yeah.
or we got a little bit too much air. And so then the computer is adjusting to get as close to that stoichiometric as it can.
Yeah, so if I know the amount of airflow going through the engine, it's really easy for me to calculate the amount of fuel that I need to reach my stoichiometric mixture. Okay, so we'll use air-fuel ratio. 14.7 to 1 is the number that everybody uses, okay? Yeah, it's kind of a round number because it's actually with the oxygenated fuels we have, it's closer to 14.65 to 1. And that's our stoichiometric mixture. The stoichiometric mixture, we've got the most complete combustion with the least amount of pollutants coming out the tailpipe, right?
Right.
That's what we want to feed our catalytic converter. And that's the whole reason we're here, is because that's why we have oxygen sensors, is because of the catalytic converter. Catalytic converters are most efficient when you're feeding it with really good combustion, right? So we have very few hydrocarbons, CO, all the pollutants are really low at that point. Our CO2 is really high. So that's what we want to push through the cat, because the cat can clean up those small amounts really well, and it'll be really efficient there. So we put the oxygen sensor in the tailpipe. Because I know the air mass going through the motor, I can predict what my injector pulse width will be to deliver that 14.7 to 1. And we can get really close. But there's all these transients. So the RPM is always changed. Everything's always changed. So we want to be able to trim it. So we use the O2 sensor downstream in what we call a feedback loop. Deliver the fuel. Is it rich or is it lean? Make a correction. Check it again. Deliver more fuel. Check it again. Deliver more fuel.
Always moving, and it's happening very, very, very quickly.
Real fast. Yeah,
Okay.
yeah. So that's what the oxygen sensors are there for. They're the final trim to get everything right.
Dialed in. So I'm driving in my car, check engine light comes on, I head down to the auto parts store. They tell me I need an O2 sensor, and they have one for $55, and they're like, oh yeah, they're changeable, and it's not a big deal. A lot of people will use the auto parts store to kind of get a little idea what the heck's going on with my car.
Yeah.
And they may have zero desire to buy an oxygen sensor and install it.
Yeah.
But it's a tool they can use. They can kind of get an idea, because they're going to go to the auto repair shop. And a lot of people are worried about getting taken to the auto repair shop, so they want to do a little bit of due
I've got no
diligence.
problem with it. A lot of techs out there are like, oh yeah, they went and got their free diagnosis at the auto parts store. You know what the people got was some information.
Right. They're just gathering data, so they
have
some sort of idea.
People don't know. They don't know. I'm not going to blame them for that. That's okay. Whenever I want to go into a conversation, buy something that I don't know anything about, I like to learn as much about it as I can, just so I have some basis for comparing my decision.
I don't really know what my CPA does. I really don't.
Yeah.
I know a few of the terms, and some things go on there, but I don't really know what he does. But I have to have a little bit of knowledge so I can help guide him in what I'm looking for.
Yeah.
So he's going to help me however he can, but he needs to know what I'm looking for. Some things he's going to say, I got it, Dave. That's why you got to have a trusted CPA, like you got to have a trusted automotive technician.
Yeah.
So back to the O2 sensor it's a messenger in the tailpipe. I'm going to simplify it. It's a messenger in the tailpipe that tells the engine and the computer, or tells the computer how to run the engine. Do I need more fuel? Do I need less fuel?
Yeah.
And there's a whole lot of other little caveats in there, things it does. But if we simplify it, we bring it down. And there's more than one O2 sensor in a car.
Yep.
So we have an O2 sensor ahead of the catalytic converter,
Mm-hmm.
and then we have an O2 sensor generally after the catalytic converter. And we could even go deeper. It's not technically before the CAT, it's an air-fuel ratio sensor.
Yeah, on the late models, so we're talking about exhaust gas oxygen sensors. So there's also what we call air-fuel ratio sensors. So the distinction to make between an O2 sensor and an air-fuel ratio sensor, both of them screw into the exhaust. If you ever pull one out, a lot of people think they resemble a spark plug. Similar, it's got a ceramic thimble in the middle of it that looks like the porcelain in a spark plug. Two totally different things, but they look similar. But the air-fuel ratio sensor has the advantage of being able to monitor and control the mixture at mixtures other than stoichiometric. So with an O2 sensor, all we know, we can determine where the stoichiometric mixture is, and we can toggle on either side of that. That means we always have a little overshoot, little undershoot. It's a feedback loop. So we add a little fuel, maybe rich. Now we measure it. It's rich. We take a little pulse width away. Now it's lean. We go back, add a little more fuel. So we always toggle back and forth on either side of stoichiometric. Now, with an air-fuel ratio sensor, they're a more linear device. It actually has the ability to respond at mixtures other than stoich. So now we can achieve this closed loop, real fine fuel control at mixtures other than stoichiometric. So I'm cruising down the road 55 miles an hour, no load on the motor. Man, maybe I want to lean it out a little bit. I'll get better gas mileage. This thing's only making 20 horse to push it down the road. It doesn't take much once that thing's going. So now I can trim it really finely.
Lean it out.
And I can get a little more gas mileage out of it. Suppose I want to accelerate, and normally when we accelerate, we want to add some more fuel. We don't want to add too much fuel. We'd like to add just the right amount. In the past, we would do what we call wide open throttle enrichment. We'd just add a bunch more fuel and dump it in. We couldn't tell how much because the O2 sensor couldn't tell us that. We only know we added more. We're richer than stoich. So what we can do with air fuel ratio sensor is we can trim it. If we want to run 13.65 to 1, we can trim it. We can hold it right there. Real fine fuel control. That helps with the catalytic reaction in the converter.
So to oversimplify this,
Go for it.
in my garage, I got a light switch. It's on and off.
On and off. Mm-hmm.
That's like your O2 sensor.
Yeah.
On and off.
Yeah.
In my dining room, I want to set the mood.
Got a dimmer.
Got a dimmer switch. So one can fine tune, whereas the other one is just on or off.
Yeah.
So we're going to fine tune so we can get exactly what we want. We want to lean it out. Maybe we want to save some fuel mileage, or we don't want to throw way too much fuel at it. Now we've got a better measuring device that can take all of that.
Yeah.
So I think that probably helps people understand. I mean, we're here to help you with your car, here to help you feel knowledgeable about it. The shop calls you and tells you need an O2 sensor, or you just left the auto parts store and they told you need an O2 sensor. What the heck is an O2 sensor? We've all got them into our cars.
Yeah.
And often there's two, but if it's dual exhaust, there's going to be four.
Yep.
And there's exceptions to everything, right?
Oh, yeah.
So that in
there's
itself.
some out there. There's some out there with 6.
Yes.
It'll wake you up when you see them. Yeah.
So all we can do is talk kind of roundabouts as far as, it's not all we can do. We could go really deep, really quick, but we don't want to lose them.
Yeah.
So, so this is what an O2 sensor is, and back to where we started is that an O2 sensor code. You go to the auto parts store, you say, oh, you got a code for your O2 sensor. Here's an O2 sensor. A lot of times that doesn't end up needing an O2 sensor. And briefly, what we want to touch on is lean codes.
Okay.
So people misinterpret it because they look at the basic, there's a code, and there's about 5 words that define that code.
Yeah.
And it's not a definition of the code, it's just a quick reference. Oh, yeah, it's related to the O2 sensor and being lean.
Yeah.
And so people say, oh, needs an O2 sensor. That's an oversimplification. But let's briefly talk about code set criteria. So that's where we find out, oh, it's not just an O2 sensor.
Yeah, yeah. So we have to be careful because we've got all these diagnostic trouble codes out there. I mean, last time I heard accounts, 3,500 codes plus in the generic mode. You know, the manufacturers, you add on all the manufacturer-specific codes, man, there's a lot of codes out there, right? So when the engineers have to define those, they have to fit into when SAE does it for global OBD2, which is, you know, federally mandated emissions program that's built right into your car. You have to come up with these descriptions of these codes. Well, sometimes they're a little generic, okay? So we'll use that P0171, 174. Those are both mean that the fuel system has determined, or the oxygen sensors and the computer have determined that our mixture is too lean. We're not getting enough fuel for the amount of air going through the engine right now. So we need to add more fuel to bring it back to stoich. So when you see the definition of those codes in your scan tool quite often, it says oxygen sensor voltage low, system lean, okay? So the first thing that people clue in on is that oxygen sensor. Well, those aren't really oxygen sensor codes. Those are fuel trim codes. Those are system codes. We do have oxygen sensor codes. P0153, P0157, that's slow response time codes. Okay, so we expect the O2 sensor to respond to those changes in the exhaust gas within a certain period of time, usually less than 100 milliseconds. We'll just throw that out there. Some are faster than that, a lot faster. 10 milliseconds for some of the air-fuel ratio sensors. They respond really quick. So we have these response codes. So those are good indicators that there is actually something wrong with the O2 sensor. But you go back to that P0171, 174, that just means the car is lean. Anything that causes it to run lean. It could be fuel pump, air leaks, mass airflow sensor reading incorrectly. There's a whole bunch of MAP sensors could cause the issue. There's a lot of different things that could cause an engine to run lean. So those are system codes as opposed to specific circuit codes or component codes. So we have to be careful with those because that's a first one. Cars roll in here. Oh yeah, I went to AutoZone and said P0171, 174, replaced all the O2 sensors. I still have this code. It still keeps coming back. What's wrong? Well, it kind of looking in the wrong place there. Those O2 sensors are telling the system that it's lean. Those
Right.
O2 sensors probably working okay. This is probably something totally different.
And now we got to diagnose why we got that code.
Yeah,
So,
exactly. So, you know, the O2 sensors also, there are heater circuits in them. They run hot. They have to, you run them 600 degrees, 400 to 600 degrees for a conventional O2 sensor. You're talking 1100 plus for an air-fuel ratio sensor. So the heater circuits are pretty important, more so with the air-fuel ratio sensors, because if the heater circuit works, they don't get hot enough to catalyze the exhaust gases, and we don't have a reaction out of the sensor. So in those cases, those heater circuit codes, yeah, usually it's a heater. Yeah, usually it's a heater. It could be wiring.
yeah.
But, you know, you have to talk about the way that O2 sensors fail. How do they fail? Physical damage. They can be poisoned. There's always this thermal shock. So the O2 sensors are built with a ceramic thimble in them. And we were talking earlier about the temperatures. So we've got exhaust gases coming out of the motor. Our combustion temperatures are 1,200 degrees plus, maybe 1,600 degrees. It can be really hot. By the time it gets to the pipe, it's cooled down quite a bit. But we were talking during a decel.
Let off the gas.
When we slow down, we let off the gas. One of the things we don't want to do is push fuel out the tailpipe. We don't need it. We're in a decel. Let's turn the fuel injectors off. We can turn the fuel injectors off and nobody knows. Turns that engine into an air pump. Now we pump fresh air, cold air, through the exhaust. Well, we just had that cat up, 11, 12, 1,300 degrees, and now we took 70, 80 degree air and pushed through it. That's a lot of thermal shock.
Or 40 degree air. It's 40 degrees outside. I mean,
Yeah.
they can get real cool.
Yeah,
So
yeah. Oh, yeah.
They got to put up with a lot.
And, you know, as soon as we get back in the gas, we dump a bunch of fuel down the exhaust. It's hot, and we just had a combustion event. Now we just, you know, there's a big changes in temperature. So they can actually crack the ceramics. So that's one of the failure modes for them. If you talk to an engineer, the engineers tell you there's no failure mode for it.
Right.
It basically reacts like a catalyst, and it will last forever.
Right. In the perfect world, they would. But
In the perfect world, they would. But we
that's a
don't
little
live in
hard on the engineer brain.
Yeah, yeah.
There's an engineer brain in me too, and it has a hard time with those kind of things. So.
Yeah.
Anyway, well, this is some insight into O2 sensors or oxygen sensors, which are really misnamed, but gives you a little bit of idea. So you have a little sort of knowledge when the auto shop calls you and says, hey, you need an oxygen sensor or an O2 sensor.
Yeah.
So now you have some understanding. Thanks for joining us, and we'll keep these topics coming to put you in the know when it comes to your car. Well, hello, I'm Dave Riccio, your host of the Bumper to Bumper podcast, and I would like to thank you for tuning in. If you want one of your car questions to be answered on our podcast, tap the link in the description for a chance to have your question featured. And while you are there, we would love for you to like and subscribe to see more Bumper to Bumper podcasts in the future.